So you want to learn shaders. They can look a bit intimidating at first, but they're really just small programs that run on the GPU. In this video, we'll keep things simple and focus on the two main parts, the vertex and the fragment shader. So let's start with something simple. Let's add a mesh and let's make it a sphere mesh. So it's going to be a little ball that's half a meter radius. That's fine. Now we want to do something with this ball. Well, first let's start by assigning a material to it. Let's add a shader material and a new shader. And we can just call it ball shader. Now, if you don't see this shader editor here, you can just press it here on the bottom. And let's expand it a little bit. And we have a few functions here. One is called vertex, and what it does is exactly what the description says. It's called for every vertex on this mesh, which means we can also manipulate that vertex. And if we switch here to the wireframe, you can see how many vertices we have. And in fact, we can probably increase it even more to, let's say, 128. So we have more vertices to work with. Now the fragment shader is going to be called for every pixel on the screen. Right now they're all white, but we can manipulate each of these pixels to get a certain color. So we'll see how to do that in a bit. And then for lights, we're happy with the default light processing. So for now, we're not going to touch this. So let's start manipulating these vertices. Let's say we want to move each vertex by a certain amount in a certain direction. And for now, let's just move every single vertex up by 1 meter. The way we do that is we get a hold of our vertex by typing vertex. Then we do .y, because that's the position we want to change. And we're going to say add 1 meter to the y position. And if you save that, you can see that now every single vertex has been offset up, which isn't very extraordinary. We just kind of translated the object. So instead of that, let's say we want to translate these pixels depending on the z-axis. So if you say move it by 1, but only if the vertex z position has some value. So now you will see that in the center, where the z is 0, there's no movement. Everything to the left, which is positive, goes up, and everything to the right, which is on the negative axis, goes down. And if you wanted to make something even more cute, we could use the absolute value of this, which means it's only gonna go up. And if you save that, we have a little heart shape. And to make it even more romantic, we can assign a color to it in Fragment. So this is gonna be called for every pixel. And we wanna say the color of this pixel is gonna be a vec3, which is just RGB values. So if I set 1 on red and 0 on green and blue, we get a nice little red heart. So let's say I want to adjust the amount of this displacement. Let's declare a variable using uniform, and then it's going to be a float, and we can call it displacement strength. And I'm just going to set it to 1 for now. Now what uniform does is exposes this variable as a shader parameter. So you can see that here in shader parameters now we have our displacement strength. So we can use it to drive our displacement here. And then if I change it here, you can see we get different shapes. You could set this parameter through code to make some animation on it. However, we're gonna do it through shaders here. So we need some function that gives us periodic movements. And the one that comes to mind is the Sine function. So let's declare another float. We can just call it animation, and we're gonna say it's sine of time. Now time is a built-in, and it's gonna give us the time since the engine has been running. However, the value of sine is from -1 to 1. So if I multiply this by animation, you'll see that this goes up, then it goes down, and we get an inverted heart. Now this may be the effect that you want. However, I want to limit this to be from 0 to 1, which means we go from ball to heart to ball. Now how can we transform this -1 to 1 into a 0 to 1? So let's say this is our sine function. It goes like this, and it goes from -1 to 1. Well, if we multiply all the values by 0.5, we get -0.5 to plus 0.5. And then if you add 0.5 on both of these values, this becomes a 0 and this becomes a 1. So now our sine wave goes from 0 to 1. So let's do that. We're gonna multiply this by 0.5, add 0.5, and now you will see our heart goes into a ball, and then it goes back into a heart. Now we can make this a bit faster by multiplying the time, and there we go. Now we can still adjust this displacement strength. It could still be a negative heart if you want. However, I want to cap this strength between 0 and 1, because if I don't, I can do something like this, and this completely ruins the effect that I want to have. So what we can do is say this is a hint range, and we specify the limits we want. So if you put 0 to 1, now I cannot set this to anything else than 0 or 1. Alright, so now I want to do something a bit different. I want to offset these vertices in the direction of their normals, and the normals on the sphere all point away from the center. So instead of just manipulating the y direction, I'm gonna do x, y, and z's. So for that we can just say plus equals And if I say +1, you can see that we are now moving in all 3 directions by 1 meter. However, I want to move that far in the direction of the normal. So we can just use the built-in normal for that vertex. And now we actually just scaled the ball because all the vertices went away from the center by 1 meter. Now, I don't want to do just the same amount for every vertex. I want to have it randomized. And to do that, we can make use of something called a noise texture. So let's declare another uniform, and it's going to be a simpler 2D. We can call it noise texture. And then if I go to the shader parameters, we can create a noise texture, and we can use the fast noise light, and I'm just going to make sure it's seamless so that there's not going to be any visible seams. Now, if you look at this texture, you can see it has only whites and blacks. When we sample our texture, we use UV coordinates, and that just tells us how far along this x-axis we want to go and how far along the y-axis we want to go. So if I want to sample a point 0.5 and 0.5, it's going to be around the center, and we're going to get a color that's either black, white, or in between. And now the black values are going to return a 0, the white ones are going to return 1, and everything in between is going to be, well, between 0 and 1. So to sample a texture, let's declare a float. We can call it noise value. We use the texture function, and we pass in the texture we want to sample, and then the UVs we want to take. So let's just use the UVs of our mesh itself. When we sample a texture, we get the color of the texture at that point. However, it has red, green, and blue channels. And since the noise is only black and white, it doesn't really matter which channel we choose. So let's just choose red. And now this noise value is going to go from 0 to 1. And the same actually for this animation because we changed it as well. So now we can say we want to offset the vertex in the direction of the normal, and instead of 1, let's use our displacement strength, and then we also want to multiply it by our noise value. And now we have a much more interesting shape. So all the displacements are now random. However, you will notice that our lightning feels a bit broken. And the reason for that is that our fragment function still thinks this is a sphere. And the way to fix this is to assign a normal map, which will then tell each pixel the direction of its normal. And with that, it's gonna tell it the correct way to reflect the light. So let's make another texture. We're gonna call it noise normal texture. And then we're gonna add the same texture again with the exact same parameters. That's very important. With the addition that we're gonna press as normal map. Now you will see that we have different colors, and then we can sample the red, green, and blues from this noise to construct a vector. So let's copy this, and we're gonna sample noise normal texture. And remember, this is gonna be a vector, so we have to change this to vec3, and we're gonna be sampling red, green, and blue channels. Let's also name this to normal vector, and then we're gonna say normal map is equal to normal vector. And now you can see we get much more correct lighting for this object. Now I want to add some life to this by using some animations. Now we already have an animation for our displacement. I also want to add an animation for sampling our noise texture. Right now we're just using a static UV. However, if we add some time offset to it, you'll see it starts doing something. Now what we could do is multiply our time by a vec2 to tell it in which direction to sample the texture. So if I just say in the U direction or in the X, it's gonna have a horizontal movement, and vice versa if I do it in the Y direction. And if I don't specify vec2 at all, it's just gonna default to 1, 1. So I can just remove vec2 and use time here. Now let's declare a variable here for the animated UV, and we're just gonna copy this from here, and then we're gonna use that variable instead. Now this is a bit too fast, so I'm just gonna slow it down a bit, and you will see now that the shadows don't appear to be moving with the object. And the reason for that is that we are still using the static UV here. Now we wanna pass this animated UV somehow from the vertex to the fragment function. We cannot do it directly. However, what we can do is use something called varying. So let's declare a varying vec2. We're gonna call it animated UV, and then instead of declaring a new vector in vertex, we're just gonna assign it to this varying variable, and then we can use it in the fragment function. Now what varying does is the following. Each vertex is gonna set a value for this variable. However, in between two vertices there can be many pixels, and the fragment function is being called for every pixel. So what it does is it takes this value, but then it interpolates between the values from the first and the second vertex. So let's say we had vertex with a value of 0, the other vertex with a value of 1. If we are halfway between those two vertices, the value would be 0.5. So that's what varying does. Anyway, now we have this nice animation from the UVs, and then we can also enable this animation we've done for displacement earlier, and now we have a ball that goes out into a weird shape like so. now what I would like to do is assign each pixel a different color, and the color is going to be dependent on the displacement that it has. Now, we assign colors in the fragment shaders, however, we are calculating our displacement in the vertex shader. So straight away, we know we need another variant for the displacement value. So let's declare a float called displacement. And then we are going to copy these three, and we're going to say displacement is equal to this. And here we're just going to use displacement for our multiplication. Now remember, our animation can go from 0 to 1, and so does our noise value, also from 0 to 1, which means our actual displacement is only governed by the displacement strength. We have to keep that in mind for what we're about to do next. But for now, let's say we want to change these colors from a starting color. So let's say starting color is vec3, and let's just say it's a white color. And vec3 ending color is gonna be, for now, let's just say green. And what we want to do is have our final color be a mix of our starting color and our ending color, and it's going to be blended with some variable. Let's just say 0.5 now for the demonstration, and then instead of using albedo with this red color, we're just going to say final color. And now you can see that the color is a mix between white and green, so you have this kind of washed out green color. Now what we want to do is make our blend value be dynamic, and we will use the displacement to drive it. So what we can do is declare a float. We can call it blend, and we're going to use this function called Smoothstep. Now I'm going to explain what it does in a second. So this is how it works. We have two edges, 0, 1, and the final float value. So it's going to take the displacement here, and it's going to compare it against the first edge, which is 0. And if it's at 0 or below, it's going to return 0. For the upper edge, which is our displacement strength, if displacement is above it, it's going to return 1. And if it's in between 0 and displacement strength, it's going to return the number between that. So now if we use our blend to drive the mix, you can see that as it expands towards its full expansion, it becomes green, and then it returns back to white as it goes back towards 0. Now what I want to do is, instead of using this green color as our ending color, I want to have a unique color for each pixel on the screen. Now if I scroll up a bit to our vertex, remember how each vertex on a sphere has a slightly different facing normal direction? Well, a normal direction is composed of x, y, and z, it's a vector 3, just the way that the color is composed of a vector 3 that has red, green, and blue. Well, we can sample the normals x, y, z and put it into the RGBs of our color. And to do that, we can simply pass it like so. And by default, it's using the XYZ. So if I put it .xyz, nothing changes. But if we want to sample the Z's into our reds and Y's into our greens, and let's say X into our blues, we can do ZYX. And now we get different colors. Now this looks pretty nice and colorful, so I'll leave it this way. Now what I want to do is fix the flickering we have at the edges of our object here. So if I go into wireframe, you'll see that we don't have so many vertices to play around with. So if we just subdivide our mesh, I'll use 512 and 256. Now we have a lot more vertices and everything looks much more smooth. So I like the look of this, and just keep in mind that the vertex function will run for every vertex you have on your mesh. So be careful about adding too many and bottlenecking your GPU. Right now, this looks fine, it works fine, and it feels fine. So I'll keep it this way. Now, I want to be able to control the frequency of this pulse. So what I'm going to do is expose another parameter. We can call it speed, and it's going to be a float, and just set it to 3.0, and then change it here in the animation. So now if I select it, we can go down to shader parameters and maybe increase it to 10. So yeah, this looks quite nice. And hopefully now we've gone over a few things here with the shaders. We've talked about uniforms and how we can use them to set their values either through inspector or passing them as a shader parameter through code. We've gone over sampler 2Ds and texture sampling, and we've gone over varying variables which can be passed from vertex to fragments, which are interpolated between the vertex values. So hopefully that gives you a good basis to start writing your own shaders. And if you come up with a cool shader, please put the code in the comments, and I would like to see how that looks like. See you in the next one.